Hello everyone. I want to talk a little bit today about the acid-base titrations lab so that you're ready to participate in it when it's time to do this lab. We'll talk about the pre-lab assignments and then the lab activities themselves. As we have done for each in-person lab, you will need to do a few things before coming to lab to prepare for it. So you will need to write the procedure into your lab notebook. That's something you'll need to do ahead of time, and complete the pre-lab quiz on Canvas for this lab. Part of this will be uploading your procedure as part of the pre-lab assignment, and then you'll be answering a few additional questions. This needs to be done before coming to lab. Do not attend lab if you are not healthy, and make sure that you have your goggles and your masks when you come to the Madera campus for lab. Again, of course, allow the time to arrive to lab at the regular starting time for the lab. I want to talk about some new equipment that we'll be seeing in this lab that we haven't seen before. First of all, we'll be using some software and probes. So that's the Vernier software. The way this works is you'll be connecting the probe to a laptop computer, and in this case, the probe will be monitoring the pH of your experiment as it takes place. So you will be doing that. You'll need to have that set up. Part of the instructions are about how to get that prepared. There are two methods in this lab. You'll be using method 1. Because of that, you'll need to be part of the lab will be you're keeping track of the volume, you're counting that, and you're inputting that into the computer as you make those measurements. This is the first and actually only time this semester we'll be using the Vernier software. And what I normally tell students as we use this equipment is that it is okay to print out the instructions for using the equipment itself and just put that into your lab notebook. The goal of the lab notebook is that you are writing out by hand the preparation of the chemicals. So that part you do need to have written out in a way that you would know what that means from your own instructions. But for the operation of equipment, it's fine to include basically the user manual for it as part of the instructions. So you can just paste that directly into your lab notebook. So that's a little bit about the software and probes that we'll be using that are new this lab. The other new thing we'll be using is the stirring plate and stir bar. There's a picture here in the corner of what that could look like. You'll have a little bit of a different model for the stirring plate, but it's essentially very similar in that it's basically what you've probably used before as a hot plate, and there was one knob for turning up the heat and one knob for turning up the stirring. We haven't probably used the stirring knob before, and we're not going to use the heat knob this time. We want it to be at room temperature, but we are going to use the stirring knob for adjusting the rate of stirring of your solution. The reason we use this is so that the pH will adjust rapidly, and it won't be based on a localized portion of the solution, so that your pH probe is measuring the pH of the entire solution at the same time. How these work is they are based on magnetism, and you'll have a magnetic stir bar you'll put into your solution. So you're seeing maybe like a little white cylinder here in this solution, and there's a magnet in the stir plate itself, and as you adjust the stirring, that's adjusting how fast that stir bar is spinning around in your solution. For this picture, what you can see is there's a little bit of a vortex forming as the water is moving around. There are a few things for this particular experiment we need to be careful of as we use the stir bar on the stir plate. First of all, you don't want to stirring so fast that solution is splashing out of your beaker. So you need to just be aware of that. And then also, you don't want the stir bar spinning in such a way that it will hit the electrode itself. So there's a bit of adjustment you'll have to do in terms of the placement of the flask of the beaker on the stir plate, as well as the speed of the stir bar or the setting of the stirring, and then of course where does the probe go? So you want to take some time to make sure all of that is adjusted accordingly. And then you'll be doing the titration itself. So you've done titrations before. This is not a new procedure, but there are some things that are new about what we're doing this time. So you will be using the sodium hydroxide you have previously prepared for this lab. If you, for some reason, do not have that, we will have some that you can use. There's a caveat, though, that your results do matter, and so it's partly based on the results of the previously prepared sodium hydroxide. As we always do, rinse the burette first with DI water and then with about 10 mils of the titrant, so sodium hydroxide in this case. If you set up, so the setup is shown here for the titration, so you'll have the pH probe, the burette, the beaker, all on the stir plate. And again, you're going to have to take some time to make sure that is adjusted correctly so that you're able to get stirring without damaging the pH probe, and then there's a bit of space for the burette to go in there as well. Again, follow the instructions in terms of how much to add. If you are careful with that part, you probably will only need to do one titration. If somehow you are doing that part wrong, maybe you have too many, or you, I guess, probably have too few additions in the steep part of the curve, then you might need to repeat it. So let me see what you get for your results on that titration before we decide if you need to do a second one. From the results of your titration, you'll be determining the concentration of the hydrochloric acid. Again, the results will matter here. Okay, so that result is partly based on your concentration of sodium hydroxide, partly based on your care with titrating for this lab. As always, when you're done with your titration, you will need to rinse out your burette, make sure it's clean. Rinse it out with at least 25 milliliters of DI water so that any sodium hydroxide doesn't solidify and clog the burette tip. Couple of safety things to be aware of here. So both the hydrochloric acid and sodium hydroxide are very dangerous. They can cause permanent eye damage. So please wear your goggles. Also make sure you're cleaning up the area when you're done just rinse with a lot of water, should be fine, to make sure that you haven't left anything there behind. That's it. I look forward to seeing you all in lab this week.